Welcome to EDU World Space.
So in this problem, we have a projectile being launched straight into the air, and the height that it can reach is h. And so what we need to do is we need to find the maximum launch speed of the projectile. So we are going to use our kinematic equation. V final is equal to the initial velocity, both of these are squared, plus 2a delta y. In this case, delta y is just going to be h. A is the acceleration due to gravity, so we're going to denote it as negative g, where g is 9.8 meters per second squared. We're looking for initial velocity, and our final velocity is when the projectile reaches the top. And so at that point, the velocity is going to be 0. So we're going to have 0 equals v naught squared minus 2gh. Solving for v naught, we see that v naught equals the square root of 2gh. For the second part, we now know that the launch speed is actually double that. So we have v naught equals 2 root 2gh. And so what this means is we have the projectile being launched at an angle so that the height, its maximum height, is still h. So what we need to do is we need to find the angle at which it is launched at. So if we draw our triangle over here, we're looking for this angle theta. So we know this is v naught, and if we just use our sine theta equals the opposite, we're going to call v naught y, over v naught. We can rearrange that, and we know that v naught times sine theta is equal to v naught y, which is what this side is. The next thing we're going to do is we're going to plug it into that same equation we had earlier. So v final in the y direction squared is equal to v naught y squared plus 2a delta y. So we can plug everything in now. V final, we're reaching this top point again. So v final in the y direction is going to be 0 again, equal to, we now have v naught y, which is this value right here. So we got to make sure to square it. V naught squared times sine theta minus 2gh again. And we can play with that a little bit. So we have 2gh over v naught squared, right? And we know v naught is 2 root 2gh. So if we square that, we get 8gh. So 8gh, sorry, this is supposed to be squared, equal to sine squared theta. So simplifying some more, we have 1/2, the gh cancels out, is equal to sine theta. I just reduced it and then took the square root of it. So we see that theta is equal to 30 degrees. Now we need to find the distance at which this projectile travels from this to this. And how we can do that is by using velocity in the x direction is equal to distance over time. Now we're looking for distance, so we need time. We're going to find time by using another kinematic formula, which is v final, we're going to use in the y direction right now, is equal to v initial in the y direction plus a t. So we know our v naught final, which is v naught times sine theta. So plugging that in, we have v naught is 2 square root 2gh times sine theta. And since theta is 30, sine theta is 1/2. So we know that v naught y is equal to root 2gh. V final, since it ends up at the same level, it'll be the same magnitude, just negative. So plugging everything in, we have a negative root 2gh is equal to root 2gh minus gt. So we're trying to solve for t here. So we have negative 2 root 2gh is equal to negative gt. So we have t equal to 2 root 2gh over g. Simplifying that some more, we have t is equal to 2 root 2h over root g. So now we can use that in our formula we had. Velocity in the x direction, delta x over delta t. Now what we need is to find the vx, but that's easy since we have the angle. It is going to be v naught times cosine, this time, cosine theta equal to v in the x direction. So our v naught, 2 root 2gh cosine 30. So plugging everything in and rearranging this formula around, we have 2 root 2gh times cosine of 30. And then putting this time over to this side, we have times time, which is 2 times root 2h over root g is equal to delta x. So now we can cancel these two out. Combining these terms, combining these terms, we get 4, so 8 h times cosine 30 is equal to delta x. So we find that the horizontal distance is then equal to, after evaluating cosine 30, 6.93 h.